Hello. Good morning, everyone. I'm Dr. Ruchika, Assistant Professor, Department of Civil Engineering at SRM University, Delhi-NCR, Sonepat. It is my great pleasure to welcome you all to this one-week faculty development program on sustainable construction practices in civil engineering. This program is organized by our Department of Civil Engineering, and I would like to thank each one of you for joining us today. We are happy to see such enthusiastic participation from faculty members, research scholars, and students from various institutes across the country. The aim of this FDP is to help us learn more about sustainable construction material, eco-friendly building practices, and how we can include these important topics in our teaching and research. Over the next 5 days, we will hear from expert speakers from top institutes like IITs, NITs, and industry leaders who will guide us on the latest technology and real-world application in a sustainable construction. Before we begin, I would like to thank our university leadership, especially Honorable Chancellor Dr. Ravi Sir, VC Sir, Dr. Pramjit, Registrar and Dean Academic Affairs, Professor V. Samal Raj Sir, our Dean Sir, Dr. Ranjit Roy, and our HOD, for their constant support and encouragement. On day one, we are honored to have Dr. Santu Kar from the Department of Civil Engineering, IIT Guwahati, who will deliver the inaugural technical session. He will be sharing his valuable insight on sustainable technology and modern practices that are shaping the future of civil engineering. Now it's my privilege to introduce our distinguished speaker, Dr. Santu Kar. He is currently working as an assistant professor, Department of Civil Engineering, Indian Institute of Technology, Guwahati. Dr. Kar earned his PhD in Construction Technology and Management from IIT Delhi and joined IIT Guwahati in October. His research focuses on essential themes such as sustainable construction, efficient material management, use of automation, and ICT in construction. Dr. Kar leads noteworthy projects in different industries like L&T and take major infrastructure projects. He did extensive teaching in project planning, contracts, quantitative methods, and construction technology. Yep. I now invite Dr. Santu Kar to begin his insightful session on sustainable construction practices in civil engineering. Once again, welcome to everyone. Wishing you a stimulating and rewarding FDP experience. Dr. Santu Kar, sir, please.
Good afternoon. Can you hear me? Am I audible?
Yes, sir. You're audible.
Okay. Thanks for the nice introduction. And I would like to thank all the organizers for organizing such a nice FDP. So, as the topic is sustainable construction practices, and in this I will be delivering some study that we have conducted that is on material management to make the material management efficient and how this material management can be sustainable. What are the different practices that can be adopted in the industry? Uh, on that, few research are being carried out by us. So I will be basically discussing those. Let me just share my slides. Is it visible? Slides are visible?
Yes, sir.
Okay. So as you know the importance of resource in the project and particularly the material which typically accounts for about 50 to 60% of the total project cost. So managing materials are very important. And also it is important to make the material management system sustainable so that overall sustainability of the project as well as the sustainability of the construction industry, this aim can be fulfilled. So in this regard, we have conducted study to enhance the material management system. And we have conducted another study on the sustainable material management. So in the context of enhancing material management, studies which basically identify the issues, the critical issues in material management, and also the investigation of the lead time. Lead time basically, if you place the order for the materials to the suppliers and then suppliers takes time to deliver the material to the project site. So this time which is basically taken by the suppliers to deliver material to the site after placing the order, this time is called lead time. So we have carried out study to see what are the different factors that basically influence the lead time of different construction materials. And also we have derived a novel classification system. I will discuss that classification system, which can be useful in the construction site to manage the inventory appropriately. Also, to enhance the material management system, we have conducted another study which assessed the criticality of the materials. Because in project site, there would be a lot of materials. Now, budget is limited, and in that budget constraint situations, we have to prioritize the materials which will have more criticality. Those materials are to be procured. And so it is required to prioritize the materials and which can be done if we can assess the criticality of the materials. So we have developed a methods here to assess or to determine the criticality of materials. We will discuss that. And further, in a project site, it is important to know how much materials are required to be purchased, when are they required to be purchased, and so that the materials are available on the project site and the executions can take place smoothly. So while we are assessing this model, it is also required to optimize the material cost and other parameters like we have to ensure that materials are available on time so that there is no shortage of materials. So considering shortage impact and different type of cost involved in procuring materials, one optimization model is developed which can basically facilitate construction practitioners to know when the materials are to be procured and how much materials are to be procured. So we conducted this study, these studies particularly to improve the material management system. So it is also required that material management system to be sustainable because then only we can achieve the SDG goals. So in order to do that, we conducted study to understand what are the different practices that can make the material management process or practices sustainable. Okay. Also, what are the different barriers which basically restricting the implementation of the practices, and what are the enablers or facilitators which can enable the implementation of the practices so that the proper strategy can be taken in the site and the implementation of the sustainable material management practices can be done in the site. So first we'll discuss the study which we carried out to make the material management system efficient. And I discussed that materials typically account for 50 to 60% of the total project cost. So it's a very important resource, and which basically to be treated with cautious, and if we can manage materials effectively, and that we can actually enhance the effectiveness in the project, and it also will help to do the better scheduling. It will also help reducing cost and can enhance the productivity. But before that, it is required to understand what is the material management, because we know materials that are used in the site, and different type of research are being carried out to see what are the different materials can be the alternatives to the usual materials to the site. But managing materials in the project site, again, another important aspect. So it is required to understand what is this material management process. So it's basically an integrated process for planning and controlling all necessary efforts to make sure that quality and quantity of materials are appropriately specified in a timely manner, and they are acquired at a reasonable cost and available when they are needed. So as per the Construction Industry Institute, they defined this process. So in general term, I can briefly tell you that material management, particularly, it's a process of acquiring materials from the suppliers. Whenever it is required, they should be procured. So timely procurement is required, and procurement with a reasonable cost is also required, while maintaining the quality and quantity of materials. So whole process, while acquiring the materials on time with a reasonable cost, ensuring quality and quantity of materials, basically said to be the material management process. Now, to enhance the material management system, before that we should understand what system is usually followed in the construction organizations. So if you see the material management system in any big construction company, the materials are procured in two ways. One is called the site procurement, another is called the central procurement. So through site procurement, basically the people or the site execution team or the site construction manager will raise the material requisition in the register. So there will be a register in the project site, maybe available in store or in the planning office, and the execution team or the construction manager or sometimes planning engineer, they will raise this material requisition on that register. And then based on that MR or material requisition, EMR will be generated on the computer-based system. So electronic material requisition will be generated on the computer-based system, and which will be further authorized and will be sent to the procurement team for purchasing the materials. Now, if it is the site procurement, then based on this EMR, then procurement team will search for the suppliers, and they'll be floating inquiries to the supplier, and supplier will be sending the quotation. So after receiving quotations from supplier, then their quotations will be evaluated by the procurement team, and finally after some negotiation, suppliers will be selected. So this is what we call site procurement of materials. In other case, while some of the materials, particularly the bulk materials, for example, cement, steel, they are procured in different way. Usually in large organizations, they are procured through the central procurement team. So central procurement team basically will receive the requirements from different projects, and based on the requirements, central procurement team will float the inquiry to the suppliers. Okay. And then similarly, they will receive the quotations from suppliers, and here the materials are for the different projects. It is not particularly for a single project. And finally, quotations, after receiving the quotations, they will be evaluated, and after some negotiation, again, suppliers will be selected. Okay. So as suppliers are selected, now based on the requirement, in case of site procurement and in case of central procurement in both the places, once suppliers are selected, based on the requirement, PO, purchase order, would be generated, and that would be sent to the suppliers. And finally, in the system, this PO would be authorized, and suppliers, once they got this PO, they basically will supply the materials based on the requirement to different project sites. Okay. In case of site procurement, that would be limited to a single project. In case of central procurement, they will be sending to different project sites based on the requirement. Now, once materials are received to the project site or store, then it would be recorded. So it is usually recorded by generating one goods inward node, which is called GIN in the computer-based system, which indicates that materials are received from the suppliers, and when they are received, how much quantity and which materials are received, all details will be specified in the goods inward node. And then it would be inspected and tested, okay, to check whether they meet the required specification or not. And based on this inspection, some of the materials, could be rejected if they are not meeting the required specification, or otherwise if they are found to be satisfactory as per the quality norms or specifications, then they are basically stored in the site, and then payment to the suppliers will be processed. Now, once materials are stored in the site, then they are further be issued to the project site based on the requirement from the execution team. So usually there would be indent kind of thing. So materials will be issued to the project site. One indent is submitted to the store, and store there would basically record which where they are basically issuing materials, how much quantity of the materials are being issued. So this way, this material management process would this process basically will follow these steps. What you can see here, the process here starts with the raising of material requisition, okay, or collecting material requirement from the project side. But this computer-based system, which in large organizations like ERP and SAP they usually use, they do not incorporate the material planning. Okay, so material planning module is not incorporated, and that's why there are several issues that are to be found. So, for example, you can see here, many a times in project side, you will see that people are talking about that some of the materials are urgently required. It is because the materials are not, material requisition is not made on time. And this is because of the lack of information about the requirement of the materials. And again, you will see in, the people who are involved in the material management process, there are procurement team, there are planning engineers, stores. So all are involved in this material management process. Now, if you see the functionality of the planning team, they know as per the schedule when the materials are required. And this schedule is rarely said, or I will say it is real, this requirement is rarely communicated to the procurement team. And so procurement team does not get to know when the materials are actually required. They will get to know once the MR is raised, and they will then start their process. And that's why the communication or coordination between the procurement team and this planning team, that is not there, and so it led to the urgency in the material requirement. Many times materials again are purchased with excess quantity, or the lesser quantity. And basically, if you purchase materials with excess quantity or over ordering is there, in that case, inventory cost of the materials would go high. Okay. If materials are less number of materials are procured in that case, it would again lead to the shortage of materials. So there could be several issues and which are being faced in the construction industry, that sometimes material are over order or they are under ordering of materials. There could be situation like that. Sometimes payment, there will be delay in payment to the suppliers as you have not added the budget availability in time. So materials, suppose a lot of materials are procured and contractor or the person who is using the materials are not able to pay to the suppliers. So delay in payment would be another issue. Late delivery of materials, if material requisition is not placed on time, there could be delay in delivery of materials. And shortage of materials could be another issue, because if lesser quantity of materials are purchased, then that could lead to the shortage of materials. So these are different issues, and what we have found that the existing computer-based system also, it does not incorporate material planning. That's why the requirement is not understood by all the stakeholders, and so timely purchasing of the materials and the right quantity of materials are not purchased, and which causes different issues. Okay, so these issues basically were taken from the industry practitioners, and some of the issues were also taken from the literature. And about 33 number of issues were, 33 total of 33 number of issues were basically listed, which were then taken for a questionnaire survey. Okay, to understand which of these issues are the critical issues. Okay, now since these issues were large in number, it was required to reduce the numbers. So data reduction technique was used, and particularly the exploratory factor analysis, EFA, we call it exploratory factor analysis or EFA, which basically a data reduction technique and can group the issues in different factors. Okay, and based on the EFA, these 6 factors were extracted, and which include inadequate planning of material, lack of information and communication, improper delivery, difficulty in transportation of materials, change in scope, financial issues in procurement. So these are the different issues which were extracted from the factor analysis. And then to understand how these issues influence the cost performance and schedule performance, 2 hypotheses were set in this study. So, because then only you can say that these issues basically are critical and they are to be managed. And to understand that, it is required to, explore the effect of these issues on the performance, project performance. So we have taken 2 project performance here, cost performance and schedule performance. So first hypothesis was developed to explore the influence of the material management issues on the project cost performance. And second hypothesis was to explore the impact of the issues on the schedule performance. So it was hypothesized that material management issues have a significant positive influence on the disruption of the project cost performance. And another hypothesis was that material management issues have a significant positive influence on the disruption of the schedule performance. Okay. Now these were required to be tested. Okay. So there are ways to test, but you can see this model. It involves the number of issues and then the factors that we extracted. And also we have dependent variables like cost performance and time performance. So it's a very complicated model, and multiple level of constructs are available here. You can see multiple level of constructs here and multiple level of dependency. For example, you can see that the dependency between the ineffective material management and the disruption of the project performance. Then dependency between these issues with the factors, dependency with factors with the ineffective material management. So multiple level of dependencies are there and multiple levels of constructs are there. And so it's a complicated model. And thus, SEM, structural equation modeling, was found to be suitable to test the hypothesis that we develop. Okay. Because if we go for regression analysis, then it can basically handle the relationship between the dependent and independent variables, but multiple level of dependencies cannot be taken care of using the regression analysis. So structural equation modeling was found to be effective. And through this structural equation modeling, basically we tested these two hypotheses we discussed. Okay. And after performing the SEM analysis, structural equation modeling, we found that these two factors, particularly the improper delivery of materials and inadequate planning of materials, are the two critical issues which are disrupting the project cost performance and schedule performance. Okay. And so they were considered to be the most critical issues and were to be addressed to enhance the effectiveness of the material management system. Inadequate planning of material and improper delivery of materials. Okay, that means an effective planning and delivery system for the materials is required in the project site to handle the different issues like over-ordering, under-ordering of materials, timely availability of timely availability of material to ensure that, so which ultimately will lead to the enhancement in the schedule and cost performance. Okay. So now we have checked what are the different material planning and delivery system available and are being useful in other industry. So we have found that the economic order quantity, just-in-time systems are different, material planning and delivery system which are being practiced in the manufacturing industry. But these, systems are not suitable as the manufacturing industry. There are differences between manufacturing industry and construction industry in terms of uniformity of demand. So here in the manufacturing industry, usually the demand should be uniform. The demand and it is uniform. But in case of construction industry, uniform demand is not uniform, and it depends on the construction schedule. So sometimes you need 20 tons of materials, for example. Sometimes you need 100 tons. Sometimes 200 tons. So the demand is fluctuating a lot, and it depends on the schedule basically. Okay. And then standardization of the products. So in this construction industry, you will see products are not standardized. Okay. A lot of materials are required and they are not standardized. So because of these issues, economic order quantity, which basically assumes the uniformity of demand, and then just-in-time system, because in construction projects sometimes there will be delay in execution, so you should have some materials as inventory, because otherwise, incorporating those delays in the construction schedule cannot be, incorporated. So that's why just-in-time system and economic order quantity cannot be directly, applied to the construction site, although they are found to be very useful to the manufacturing industry. So for construction industry, you need a specific strategy for material planning and delivery. Okay. So to improve this material planning and delivery system, we need to incorporate the critical aspects of material planning delivery. We have taken three critical aspects here to enhance the material planning and delivery system. One is the lead time of material. Another is the criticality of materials to prioritize their procurement, and then optimum material procurement schedule. Okay. So if you know the lead time, then only you can raise the material acquisition on time, because you know the requirement of the materials. If you can estimate the lead time, or if you have idea that what would be the lead time of the materials, then you can raise the material acquisition. Then again, prioritizing materials are very important, because budget is limited, so all the materials cannot be purchased at the same time. And in this budget constant situation, it is required to assess the criticality of materials, which basically will help to prioritize the materials. And that way, we can basically improve the material management system. And finally, it is also required to know when the materials are to be delivered to the project site, considering that cost, the transportation cost or the ordering cost of materials, then the inventory cost, the capital cost of the materials, the capital lockup. So considering all the different costs that are involved in this purchasing process, and also incorporating the shortage impact, means the materials should be available on time, otherwise there would be penalty, which you can say the shortage impact, that are to be incorporated. And then finally, a material procurement schedule should be developed, which will help construction practitioners to procure the materials on time with the right quantity. Okay. So now I will discuss these three studies regarding the lead time, criticality, and the development of the optimum procurement schedule quickly. So in this lead time, we had three objectives. So we assessed the lead time of materials, classified the materials based on the lead time, and also checked what are the different factors that can influence the lead time, which will help in estimating the lead time. Okay. So to classify the lead time, you can see here we have basically analyzed about 4,56,553 material procurement data, where which were basically collected from 16 building construction projects. Okay, and we have taken 24 materials and their lead time from a large organization. And you can see here, these are the materials: reinforcement bar, RMC, cement, stone aggregates, plywood, tiles. So these materials are basically contributing about 80% of the total material cost, and they are taken in this study. And then the cluster analysis was performed to classify the materials. Okay. So a two-step clustering method was adopted here, which included hierarchical clustering to see the number of clusters. And then taking those number of clusters, we conducted a non-hierarchical clustering to classify the materials in different clusters. So from this two-step clustering analysis, materials were classified into three different clusters, and those clusters were named as the long lead, moderate lead, and short lead. So LMS classification system, which is a novel classification system, new and novel classification system, based on the lead time, was developed. Okay, long lead, moderate lead, and short lead. And you can see the materials which were classified as the long lead, which included reinforcement bar, cement, plywood, rebar, coupler, tiles. Okay, and then moderate lead like admixture, silica fume, AAC blocks, okay, bricks. Short lead like sand, stone aggregates, then slag. So this way, through the two-step cluster analysis, materials were classified into different into three clusters, and LMS classification was developed from this study. Okay. Now there are different classification system already available for the materials, like ABC classification system, which categorize the materials in A type, B type, and C type based on their usage value. Okay. Then there are classification system like VED, vital, essential, and desirable, and where the materials are classified into these three category: vital, essential, desirable, based on their cost of shortage. Okay, and then there is another classification system, that is HML: high, medium, and low. So here materials are classified based on.
ये सब बात कहाँ से आया? कौन लिखवाया? कौन लिखवाया?
Can you please mute? So we developed this LMS classification system that can be incorporated with the existing classification system that I said: A, B, C, D, E, D, FSN, HML. Any of the classification system can be combined with this LMS classification system, and that way the inventory of the materials, inventory management of the materials can be improved. Okay. Then we also checked what are the different factors that basically influence the lead time. Okay, then only you can assess the lead time of materials, and you can raise the material acquisition on time. So from the literature, we identified 4 factors which may influence the lead time of the materials, which are also checked with the construction practitioners. So unit price, order value, project value, and supplier's capacity. These four factors were taken to examine their influence on the lead time of material. So four hypotheses were tested here. Four hypotheses were set here. First hypothesis was the lead time of the construction materials is positively related to the unit price. Lead time of the construction materials. The second hypothesis is the lead time of the construction materials is positively related to their order value. Third hypothesis is the lead time of construction materials is negatively related to the project. Okay. And then fourth hypothesis, capacity of a supplier has a negative influence on the lead time of bulk materials. Okay. So these hypotheses were basically examined through the regression analysis, and in this regression analysis, taking lead time as the dependent variable and unit price as the independent variables, this regression analysis was performed, and we found the standardized coefficient beta as positive, and this is significant as less than the p value is less than 0.05. So which says that unit price has a significant positive influence on the lead time of the construction materials. That means H1, hypothesis 1 is not rejected. So we tested hypothesis 1 this way. Then hypothesis 2, 3, and 4 were examined through another regression model, and that is multiple linear regression analysis was performed to check the effect of project value, order value, and supplier capacity, taking them as the independent variables and lead time as the dependent variable. So from this regression analysis, we found that the beta value is negative for the project value, and it is also significant, and that is also for all the different material categories: long lead, moderate lead, and low lead. Okay, so which indicates that project value has a significant and negative significant impact on the lead time of the construction materials. On the other hand, order value was found to have a positive significant impact, as the beta value was positive for the order value, and it was significant as p value is less than 0.0. Less than 0.05, it is 0.0, so less than 0.05. So you can see here that from this hypothesis it can be concluded that order value has a positive and significant influence on the lead time of the materials. And then third factor, that was supplier's capacity, and the beta value for that was negative, and it was also significant. So the hypothesis 4 was checked with these values, and it can be concluded that supplier capacity has a significant and negative influence on the lead time of materials. So finally, H2, H3, and H4 were not rejected. Okay. So this way, by performing the regression analysis, we examined the influence of the project value, order value, supplier capacity, and unit price on the lead time of the materials. Okay. So you can see here, this is the output of the regression analysis. So project value basically influence negatively to the lead time, supplier capacity influence negatively, order value positively, and unit price positively. And materials lead time is shorter in higher value project compared to the lead time of the same material in lower value project. Usually what happened, if you have a larger construction project, there will be less time to complete the project, because project duration is not usually proportional to the project value. Thus, project team member, they will put more effort and better coordination into the delivery of material, and that is why for a higher value project, materials lead time will be shorter. Okay, because of the greater effort by the project team members, as they will have lesser time duration compared to the project which will have a smaller value. Then lead time of a material increases as its order value increases. Correct. That was explored from the hypothesis test, or from the regression analysis. We have understood this. So if order value of a material increases, then suppliers require more time for production. If I say instead of 20 ton, you have to produce 100 ton, then to produce that 100 ton of reinforcement, you need more time. So as the material order value increases, then it will take more time to manufacture or produce that material. So the lead time of the material should be increased. Then supplier capacity is another important factor which was found from this study, because as the supplier capacity increases, means supplier will be able to manufacture more materials. They will have better facility. So, lesser would be the lead time of the materials. Okay. So this way we examined the influence of different factors on lead time, and which will basically help in assessing the lead time of the materials and understand the time required to deliver the material after placing the order to the site. And again, that way, one can raise the material requisition on time so that materials can be available in the site on time. Okay. Next study was to develop the optimum material procurement schedule. Okay. So in this material procurement, it is required to optimize the cost of the materials. Acquiring right materials, right time, from the right source is required, because then only the timely and budgeted completion of the project can be ensured. Again, there will be limited budget. So, material procurement schedule or the procurement of the material should adhere the availability of the budget. It is also required to assess the criticality of the materials, because in this budget constraint situation, you have to prioritize the materials. Okay. So that's why the optimum material procurement schedule was required. Okay. And in this, we consider the different cost component which are involved in this procurement of materials, like ordering cost, storage cost, capital cost. Because if suppose in a 12 months project, materials are required, some of the materials are required suppose in every month. If I say you need to carry out concreting work in this project, so you need concreting in different times, and sometimes you need suppose for the concreting you need 200 bags of cement, sometimes 20 bags of cement, sometimes 50 bags of cement. If you go for purchasing in every month, then what would happen? The cost for transporting the material and the ordering cost of that material should go high. But if you purchase the material with the lesser ordering, suppose instead of placing orders 12 times for 12 months, if I place order for one time or two times, what would happen? I can reduce that transportation cost or the ordering cost, but then the storage cost and capital cost of that material should go high. Okay. So that means, reducing the number of orders again would enhance the storage capital cost. Again, to reduce the storage or capital cost, you have to order frequently, which will basically increase the transportation and ordering cost. So there should be an optimal balance, okay, which basically can take care of this ordering, storage, and capital cost. Also, you have to ensure that materials are available on time. That means one should incorporate the shortage cost. Means if materials are not available on time, there would be penalties, because execution cannot take place. Material would be shortage there in the site. So one has to incorporate the penalties due to the shortage of material in the model. Okay, optimization model. And it was found from the literature that the integration with the construction, integrating construction schedule in this material management system, incorporating budget, and then considering the impact of unavailability of materials, incorporating storage capacity. So these things are not basically incorporated in the the models that are being developed in past studies. So it was required to incorporate all these aspects. Okay. And finally, we developed a model. So this study was carried out in two steps. In the first step, we assessed the criticality of materials, and then a material procurement schedule was developed that was capable of incorporating the construction schedule, material criticality, and that can optimize the procurement cost and can adhere the storage capacity and available budget for material procurement. So this was carried out in two stages, as I said. In the first step, criticality of the materials were assessed. So for that, basically some of the criteria which criteria of the material criticality were identified from the literature, and criteria were also discussed with the industry practitioners. Then questionnaire survey was conducted to assess the weights of the criteria, and ANP analytic network process method was adopted for this, and to assess the material criticality, okay, of the materials based on the weights of the criteria for the TOPSIS method was followed. So through this ANP TOPSIS, the criticality of the material, particularly MC value, material criticality, was assessed for different materials. Then activity criticality was another criticality which depends on the floats available to the activities for which materials are required. Okay, based on that, activity criticality was assessed. And then finally, combining this material criticality and activity criticality, total criticality value was calculated, and that was considered for prioritizing the materials. Okay, and also it was considered as the shortage impact in the material procurement schedule or the optimization model I will be discussing. So this material procurement schedule was developed in the second stage, and for that, initially material requirement plan was prepared based on the construction schedule, and then one optimization model was developed, which included the ordering cost, the storage cost, the capital cost, and also the shortage impact of the materials. Okay, and then optimization was performed using NSGA tool, that is non-dominating sorting genetic algorithm tool, which developed the optimum material delivery schedule, and finally incorporating the lead time optimal procurement schedule was developed. Okay, and it was illustrated in a building project to see the benefits of applying the model to the project. Okay. So MC, AC, and TC we discussed. MC was calculated based on certain criteria, and as part of the ANP process, initially the interrelationship among the criteria were assessed, and this interrelationship were considered to determine the criteria weights to this ANP process, and you can see the weights of the criteria uh, and their rankings. And based on the weights of the criteria, finally TOPSIS was performed. And for the, in this TOPSIS method, initially decision matrix was developed, and then normalized decision matrix, weighted normalized decision matrix, then ideal solutions were generated, and then relative closeness to the ideal solution was calculated, which basically the MC value, material criticality value. Okay. So for different materials, you can see the MC value were calculated through this TOPSIS method. And then based on the float available to different activities for which materials are required, the activity criticality of different materials are calculated. Okay. And these are shown here. And by combining this material criticality and activity criticality, finally, total criticality of the materials were calculated. And this total criticality were considered to be the shortage impact in the optimization model. So if materials are not available on time, there will be a penalty, and this penalty was defined by the shortage impact. Okay, and to define the shortage impact, the
Hello, sir, you are not audible. Sorry to disturb you. Dr. Santu Kar, sir, you are not audible.
Now, am I audible?
Yes, sir, perfectly audible, sir.
Sorry, there was some internet issue, so I was disconnected. So up to what I covered, can you please let me know? I was discussing this optimization model.
Sir, slide number 32, sir.
Okay, so I was discussing the optimization model. So whether you were here or not. Okay, I will again repeat this optimization model. So for developing the optimum material procurement schedule, am I audible?
Yes, sir, you are.
Okay, thank you. So to develop the optimum material procurement schedule, the optimization model was developed, and where we included two objective functions. First objective function was minimizing the procurement cost, that is to minimize the storage cost, capital cost, and storage cost, capital cost, and ordering cost of the material. And then second objective was to minimize the shortage impact. Okay. And this total criticality, which was calculated in the first step, this was considered as the shortage cost, shortage impact here in this objective function 2. And then we defined some of the constants as purchasing cost should be less than equals to budget. Then total procured quantity should be equals to the total required quantity. Procured quantity at any time should be more than or equals to minimum order quantity, because if suppose in a month you do not have much RCC work and you need very less amount of cement bag, and if it is lesser than minimum order quantity, then purchase and suppliers may not be interested to supply the materials. They would like to combine the materials the next order. So that's why the material delivery schedule or the procurement schedule that should adhere this minimum order quantity. And then storage quantity at any time should be less than equals to maximum storage capacity, because you cannot purchase huge number of materials which cannot be stored in the site, correct? Then materials should be, they would be damaged. So the storage capacity of the site should also be taken care of, so that the results that you are getting should be applicable to the site, would be more practical. Okay. And then the order quantity should be considered as the multiple of the standard shipping quantity. Because if suppose a truck load is suppose 20 metric ton, and if you are placing 70 metric ton to the supplier, you are placing an order of 17 metric ton, then this truck would be the empty truck. So that means, in that case, the more number of transportation would be required, and which again will enhance your transportation cost or ordering cost. That's why it was considered that ordering cost quantity should be multiple of the standard shipping quantity. Okay, so considering all these constants, then NSGA2 through NSGA2, non-dominating sorting genetic algorithm 2, this optimization was performed, and for the illustration of the model to a project, this these activities were considered, including RCC in phase 1, phase 2, brickwork in phase 1, phase 2, plastering phase 1, phase 2, and flooring phase 1, phase 2. So these activities were considered. The works were executed in 22 weeks as per the schedule. Okay, it's a building project. And these are the input parameters for this model. So the TC value was required for the model, and the unit price of the materials, the minimum order quantity, standard shipping quantity, maximum storage capacity in the site. Okay, so these were considered as the input for the model. And then after performing this optimization, the optimized material delivery schedule was generated. Okay, you can see this optimized material delivery schedule here for different materials we consider for this study. So cement bags throughout this 22 weeks, when they are actually required to be delivered, that is written here in this table, that is included in this table. You can see that in the first week, 1,000 bags of cement is required to be delivered. In the fourth week, 450,000. So you know now what exact quantity of that materials are to be delivered and when they are to be delivered. Okay. By considering that all the time the order quantity is more than or equals to the minimum order quantity, and also they are multiple of the standard shipping quantity. Okay. So the requirement could be that for every month cement is required. Instead of delivering materials on every month, you can see this optimum delivery schedule after optimizing the cost and reducing the shortage impact. It says that materials should be delivered on week 1, 4, 5, 9, 11, 16, 17, this way. So can exactly what quantity of bags are to be delivered, that is also written. So this will help construction practitioners to raise the material equation on time. Now they know that materials are to be delivered on 4th week. So if they know that the time it requires to deliver, I mean the lead time, if they know for the cement bags, they know that by this month, if I say this is 1 week for cement bag, then they know that on week 3 material equation is to be placed, so that materials of this much amount, so that this much amount of cement bag would be available on week. Okay, so this way they can now prepare the material procurement plan or material requisition plan. Okay, you can also see here the results or the optimized material delivery schedule also adhered the budget that is available to the project side. Okay, so the cumulative budget that is available is written here in this row, and you can see here the cumulative purchasing cost at any time that is lesser than or equal to the budget. That means you will not have any issue to pay to the suppliers. Okay, so payment to the suppliers was another issue which has been incorporated in this. Over ordering, under ordering of material has also been incorporated in this. Shortage cost, so shortage impact has also been incorporated in this model. So this way, model would be more effective, or the delivery schedule that is generated would be effective to the construction project site, and it is again practical as it is considering the storage capacity, considering the minimum order quantity, and also considering the standard shipping quantity. Okay. Finally, this was compared with the optimized, this was compared with the actual delivery schedule, the schedule that was, followed in the project side, and it was found that the procurement cost was saved by 31.17% using the optimized delivery schedule, and shortage impact was reduced by 83.47% while using the optimized delivery schedule. Okay. So most of the conclusion parts I discussed. Okay. Now coming to another study which I indicated initially, that so all these I discussed, that is towards the effective material management system, how you can make the material management system effective so that issues regarding the material planning and delivery can be addressed. Okay, and they're practical also. Then another study in the context of sustainable material management was carried out. Okay, so we often carry out research to understand what are the alternate materials which can basically replace the cement and can reduce the carbon footprints. But this is not this is not only the way of enhancing the sustainability in this material procurement or material management process. There are different other practices which can actually lead to the sustainable material management or can lead to the sustainable construction. Okay, and that basically would be discussed in this. So as you know, there are different materials required, and that basically will cause the different issues will be impacting environment and will be causing some social problems, like they are responsible for climatic changes due to greenhouse gas emission, depleting natural resources, degradation of air, water, land, wildlife habitat. So these are different environmental and social problems that are being caused due to the use of the large number of materials in projects. Thus, it is required to have the material management system sustainable, to reduce the negative impacts to the society and to the environment. Okay, so that's why the engagement of SMM practices is very much needed, and it is need of the hour to enhance the sustainability in construction. Okay, and materials, as I said, it basically contributes 60 to 6, about 60% of the total project cost. That means, enhancing sustainability in this material procurement basically will, will be contributing a lot towards the sustainable construction. So here, basically, two objectives were set as to identify what are the different barriers, critical barriers that basically are restricting the implementation of the sustainable material management practices, and what are the different enablers that can be, adopted in the project site so that they will basically help to implementing the SMM or sustainable material management practices. Okay. So again, you see the research methodology. It involves, identifying the practices and the barriers and enablers from the literature, and then it was followed by a questionnaire survey. And based on the questionnaire data, then factor reduction, data reduction technique was used, like EFA, exploratory factor analysis, which basically extracted factors. And then with these factors and the various enablers and the practices, a model was developed. And through the SEM analysis, structural equation modeling, the hypotheses which were set in this study were tested to understand which of these barriers are, or whether these barriers are critical or they are disrupting. I mean, they basically are disrupting the implementation of the sustainable practices, or the enablers which are there, whether they are facilitating the implementation of the sustainable practices. So these are some SMM practices. So to make the material management sustainable, or to make the construction sustainable, it is, as I said, it is not only it is not only to focus on the alternate materials which can reduce the carbon footprint, but other practices like one should use the life cycle analysis for evaluating the purchasing of materials, participating in the design of products which are amenable to recycling or reusing, ensuring safe transportation, fuel efficient transportation, then ensuring safe working practices, ensuring labor laws that are followed in the project site, and then providing training opportunities, purchasing from the local suppliers, using locally available materials. So all these practices will basically lead to the sustainable material management or sustainable construction. Okay. So this way, one can, if one organization they follow, or if it is followed in the construction industry, then basically it will lead to the sustainable construction. And but why they are not followed? There must be some barriers. What are those barriers? And again, to easy or to make these practices implemented in the site, there should be some facilitators. So then what are the different facilitators that were basically explored? So from these practices, 17 practices from the EFA, factors were extracted, and then again barriers and enablers which were identified from the literature or from the practitioners were large in number. So they are again reduced, and factors are extracted from the barriers and enablers, and total of 4 factors from 16 barriers were extracted, and 5 factors from the 20 enablers were extracted. And then these 3 hypotheses were set. One is that SMM means sustainable material management enablers have a significant positive influence on the implementation of SMM practices. Second hypothesis was that these SMM barriers have a significant negative influence on the implementation of SMM practices. And third hypothesis that implementation of SMM practices have a significant positive influence on the overall SMM engagement. And again, if you see the model here, it is quite complex, as it involves multiple level of constructs, multiple level of dependencies, and so SEM was adopted. And from the SEM analysis, it was found that you can see the standardized coefficient between SMM enablers and SMM practices, it is 0.35, which is positive. And SMM barriers and SMM practices, it is negative. Okay. Also, SMM practices and SMM engagement in between this standardized coefficient is positive. and all the p-values associated with this were less than 0.05. So these three hypotheses were not rejected. Okay, as beta value you can see for this first hypothesis, where we hypothesize that SMM enablers have a positive influence on the implementation of SMM practices. So this value is positive as well as it is significant. In this hypothesis too, we consider the negative influence, and this was significant. So from the SEM analysis also you can see that the value is negative. Okay, and you can also see that p value is less than 0.05. Okay, so this hypothesis was also failed to be rejected. Then third hypothesis, again here you can see the beta value is positive and it is less than 0.05. So again third hypothesis also failed to be rejected. So from this study, we found what are the critical enablers, which basically will help in implementing the sustainable material management practices that included optimum use of resources and CSR initiatives. It included stakeholders' commitment, HSE initiatives, government directives, organizational initiatives, and then critical barriers that can basically disrupt or restrict that the implementation of the SMM practices, which included inadequate strategies, policies, regulation on SMM, inadequate resource and managerial attributes, lack of support from organization and other stakeholders, unethical professional practices, and also from the hypothesis we found that these barriers and enablers have a significant influence on implementation of SMM practices. Okay. So it can also be concluded that practitioners and policymakers should consider these enablers and barriers, and then only the effective implementation of the sustainable material management practices can be ensured in the construction projects and construction industry, which will basically lead to the sustainable construction. Then it is also required to enhance the project participants' awareness of the benefits of the SMM, promoting technology to drive SMM, and one has to take hard steps to reduce the unethical practices, which basically will lead to the sustainable material management again. Further, the SMM engagement, to enhance the SMM engagement, organizations should participate in the philanthropic activities to mitigate social problems. They should encourage the innovation to avail more sustainable materials and take steps to improve the air and water quality. Stakeholders' commitment. All the stakeholders should have the commitment. They should support the implementation of the SMM, and then only this ultimate sustainable construction can be achieved. So it is required from the stakeholders end. It is also required from the government side. So importance of strategies, policies, and regulations on SMM and government directives for SMM implementation is also required. As you can see here, the government directives was found to be one of the critical enablers, and lack of strategies, policies, and regulation basically restrict the implementation of the SMM practices. That's why this study also indicates the importance of strategies, policies, and regulation on SMM and government directives from for SMM implementation. Okay. Then again, when purchasing the materials, life cycle analysis should be carried out to evaluate the materials. Sustainability criteria should be considered to select the suppliers, and then fuel efficient transportation should be ensured to make the material management process sustainable. And again, it should be mandated in the contract document. Contract clause should, there should be some contract clause on social and environmental aspects of sustainability. And if it is included in the contract clause, then only it would be followed in the project, and it should be mandated by the the owner. Okay. So these efforts, if they are applied by the policymakers or the stakeholders, the practitioners from the government organizations, then only it would help to advance the sustainable material management engagement in the construction industry in India and in other countries, will ultimately enhance the sustainability in construction. Okay. So we published some in some journals. You can see ASC Journal of Construction Engineering Management. So these some published. These are some other publications. So we are also carrying out research in the context of sustainability. So we recently have published one paper in ASC JCM, Journal of Construction Engineering Management, where we identified what are the different methods which enables sustainable social sustainability, which enhance the social sustainability. What are those execution methods? We carried out a research. We carried out research on some labor productivity, then carried out research on optimizing labor acquisition. We are also conducting research in the context of automation in construction, particularly enhancing safety while integrating with digital technologies like building information modeling, and then integrating it with VR, virtual reality, augmented reality. Also, some progress monitoring using this VR AR, automating the construction schedule. That is another study we are conducting. Okay, we conducted some studies also in the context of leadership development, how leaders EQ, SQ, resilience, okay, flow state. These basically impacts the leadership development. We also conducted some studies on risk management, particularly the risk management practices, the issues in the renewable power projects. Okay, so these are different studies we conducted, and so a few we discussed. With this, I would like to conclude. Thank you.
Thank you, sir, for the wonderful session. We have learned so many good things about sustainable management system and material planning and delivery, how we deliver in industry. We gain such a good knowledge. So, requesting all the participants, if anyone has some query, please drop the message or raise the hand. Anyone has? Oh, thank you, sir. I'm requesting all the participants, please turn on the camera so that we could click a picture or group photo. Please turn on the camera, please. Okay, thank you.
Thank you.
And we'll update tomorrow's schedule on the WhatsApp group. Thank you, sir, for such a great time.
Okay. Thank you.
Thank you, all the participants.